Hey guys, welcome to the tutorial regarding Simpson's rule. Now I will like to explain about Simpson's rule and how to do integration by Simpson's rule in Fortran code. That is the topics of my discussion today. Here, first of all, let us suppose the function is f of x and we want to integrate it between the interval a and b. Then in Simpson's rule we have to divide this interval a and b into n number of sub intervals of equal width, and the width is of course delta x, and this delta x can be calculated by using b minus a over n, where n is the number of equal sub intervals. Okay, so the interval started from x naught and ended at xn, such that x0 equals a and xn equals b. Okay, so this is our Simpson's rule formula. Here delta x, I will denote this delta x by h in the Fortran code. This is h over 3, the first function f of x0. Similarly, last function f of xn, of course they are f of a and f of b. And then see, this is the pattern. The f of x1, f of x3, f of other x odd numbers are multiplied by 4. So in Fortran code we will add up all the functions relating to odd number of intervals like this. So we will add all the odd intervals and then multiply it by 4. Then we will have all these sums in the Fortran code. Similarly, see, these are the numbers x2, x4, etc. are multiplied by 2. But remember that this is the first value, so in the first interval we will not multiply. So x0 will be excluded in the multiplication in the sum. Similarly, xn is included because we will add up these functions separately. But listen, we will start from 1 to n minus 1 in case of odd number, but we will start from 2 to n minus 2 in case of even number function. So okay, this is the formula. Actually the formula is delta x or h over 3 f of x0 plus f of xn, or simply f of xa, f of a plus f of b, and then the sum of all functional value with odd number of intervals times 4 plus sum of all functional value of even number times 2. Okay, so we will write how to find integration using Simpson's rule in Fortran. Okay, now we will open terminal. So for opening terminal you have to press Ctrl Alt T as a shortcut. So my terminal opened. Now we will create a document in the .f90 format for Fortran. So let us write this, and I will use gedit for this purpose. So first of all I write gedit, and then I will write file name Simpsons rule.ef90. This is the Fortran 90 format. So to run program in the background I will write end. Now this program will open. So I start writing program for Simpson's rule. So I will write Simpson as a name and then end program. Okay, so this is the format of my program. I write implicit none. You know what is the function of this. Okay, first of all let me define function here. Okay, so real function is this is the real function. So let us write f of x here and then in function. Okay, so let me define this as well. So this is real number, of course, is the function of x, and f equals, let us define a very simple function. we should just integrate this. Okay, x square is my simple function, and then to call this function I need to use real external here. So the name of function is f. Okay, so whenever I call this, I write f of x, then this function will appear in my program. Okay, this is the program, this is the function. So function is generally written outside the program. Okay, so let me start programming of Simpsons rule. First of all, let me write something. Okay, we will define some parameter, real, x, a, b, etc. Okay, we will write whenever we need these things. Clear? Okay, so first of all, print, please, no, sorry, welcome to the Simpsons integration, sorry, method using Fortran. Okay, so first of all this will appear, and then I think we need to start up writing things better. Okay, so first of all, please insert the lower limit integration, and then the we need to read that. So okay, it will be read as a, and then again again please insert the lower, oh sorry, this is upper, so upper limit of integration, close it, and now read as a, sorry, read, and now it's b. Okay, so this is b. So we have written this again, print, please insert the number of sub intervals, and read yan. Okay, so I have not defined the yan here, so okay, sorry, yan is generally integer, so it is better to write define integer as yan. Okay, so we will write yan here, and then let us find yat. What is yat? Actually yat is the width. Okay, so width is simply b minus a divided by yan. Okay, I have not defined yats, whether it's real or integer or something else, so it is better to define it as real. Okay, so this is yats. Now what we do is, okay, so we have calculated yats. Now let us move to the, this is the function, and we have to find integration. Okay, for that, as I previously mentioned, we need something, okay, addition of odd integer functional value and addition of even integer functional value, and then first and then last multiplied by 4 and 2, etc. Okay, so first of all, let me write the formula. Okay, so let me write as integration Simpsons. Let me define it by Simpson integration. Okay, Simpson only. This is the integrated value. Is it clear? Okay, so Simpson equals, first of all, yats over 3, yats over 3. Okay, this is our formula, and it is better to enclose this in the brackets. So to find real number, it is better to write dot here, yats by 3 into, okay, so yats by 3 into bracket f of, as I previously mentioned, f of a plus f of b, okay, plus f e1 and Okay, first of all write f odd here, odd, and we need to multiply it by 4 times sum of odd. Okay, sum of odd, and then plus 2 times f even. Okay, this is our formula. Actually this f odd means sum of functional values of odd subintervals between x1 to xn minus 1, and this f even is the sum of functional value with even intervals between x2 x2 to n minus 2. Okay, and then multiply it by h by 3, and this is the Simpson's rule. Okay, I have used few new terms here, Simpson, f odd and f even. That's why it is better to define it. Okay, so maybe integration is real number, so let me define it by Simpson in the real sense. Similarly, f odd is not defined now, so this may be real, and f even, sorry, this is the spelling mistake. I think it should be odd. Okay, so f even. These are my this is my integration formula, and this is my definition. Okay, so let us find f odd and f even first. Then we have a very simple logic for that. Okay, you know well, whenever we want to do sum of some numbers, then it is better to use do loop. Okay, so first of all let me define I over here so that I can use do loop now. Okay, this is our formula. Now let me define do loop. Okay, so do wait. Okay, no problem. Do I equals 1 to, first of all let me do even odd number, so n minus 1. Okay, so n minus 1, but here how to separate this odd number? To separate that, first of all let me define a new number m, such that m equals n over 2. Okay, so I have not defined m, so this is integer, of course, so it is better to define it in integer. Okay, this is m, and yes, now the reality is c. So this, okay, so whenever we want to find odd number only, then it is necessary that the number runs from, for instance, let us take example 10. We will divide into 10 equal subintervals. Then okay, x1 will be of course x1, and last value would be x9. For that, to have a exactly odd number, this m should run from 1 to m minus 1. How this happens, let me explain it later. Okay, this is do I equals 1 to m minus 1, and let us define sum. Okay, f even, f odd equals okay, so f odd equals what? F odd plus the true function is f of a plus p asterisk into h, such that, okay, so let us not define this. The odd number is always, of course, 2m plus 1. Yes, so this is our odd number, and multiplied by, sorry, outside the bracket, multiplied by h. Okay, so this is the function is f of x, sorry, I have not enclosed in bracket. Okay, f of x, this bracket and this bracket include x, but here x is always a plus I h, you know that. Suppose to find ith as always odd, this should be the value of I should be twice m plus 1, such that m equals n over 2. This simply 2m plus 1 simply ensures the I is always odd number. Clear? So that's why. Okay, let us take example as there are 10 sub intervals, then we should have numbers only up to 9. So to have 9 in here, in the value of 2m plus 1, the yam should be of course 4, right? So in 10 intervals we should have 4 as m, means simply 10 over 2 is 5, so 4 is of course m minus 1. So the maximum value runs from 1 to m minus 1 in case of odd number. Okay, so why I use a plus twice m plus 1 into h here? This is simply f of x, and this x is a plus ih, of course. So to ensure I as odd number, I included twice m plus 1 in here. Okay, so this is nothing but just twice I plus 1 here, twice I plus 1 here. So this simply ensures the value of I runs from 1 to m minus 1. So here in place of I we will substitute m, and whose value runs from 1 to m minus 1. So this simply ensures odd number, and okay, this is f odd. Okay, I think we define it. Let us in this into. Okay, yes, so this is our sum, but here I have not defined f odd. So the first value of f1, f odd, is of course what? F odd equals 0. So okay, so I equals 1 means simply 2 into 1 plus 1 is yes, 2 into 1 is 2 plus 1 is 3. Oh sorry, the simply minor mistake happened here. This should run from 0 to m minus 1, because value of I equals 0 means 2 into 0 plus 1 is 1. So start from 1, simply I starts from 1 means this value starts from 1 means I should start from 0. Okay, so the first value is f1, of course 0 plus a plus 1 into h is a plus, simply a plus h. So 0 plus a plus h is of course f of a plus h. So this is our first value, and then the answer will be accumulated in the storage. And again for I equals 1, this would be 3. So we will have f of x3 here. So first value is added to the f of x3, and then again the process continues unless the value of I runs from 0 to m minus 1. Okay, simply this explains the sum of all numbers, sum of all functional values. Okay, so in the same way we can do f even as well. So let us start do loop again. I runs from, of course here f of x2 to f of x n minus 2 is on the formula. So it is better to start from I equals 2 to m minus 2. Okay, so this is our do loop, and then end here, do, and yes, this is our format. So do yes, let us define that f even equals, of course same pattern, f a1 plus f of a plus twice. Okay, to ensure number to be odd, we will have twice I here, because this is always whatever be the value of I, 2i is always odd. So whenever we multiply this by yards, and this is simply f of x, and this 2i ensures this is odd number, so this is simply f of x odd, x even. Okay, so this is our formula, but the first value of f even is not defined, so let us define that here. F even equals 0. Okay, so this is our formula, and maybe this is the final code. Okay, so let us write print here, because we need to print this on the results. So the integrated value is using simson rule is okay, comma, the answer is of course our Simpson. This is our answer, so it is better to print this here. Okay, yeah, it is better to print some other thing also, because whenever we find answers, then it is better to realize things or analyze things in the better way. So print what lower limit equals, yes, a, and then print our limit equals b, and this is our answer. Okay, so let us try this. First of all, let me save it, and then again move return to the terminal. Yes, this is our terminal. So first of all, compile it. Maybe some error may happen, but we can fix this. So to compile it, Fortran, Fortran Simpson run this. Okay, so yes, there are lots of things that symbol this a and b has not implicit type. Okay, these are some errors. Yes, let me fix it, and then we will move to the answer. Okay, so problem is at this name. Actually, this is the name of the program, and I'm using the same name on the variable as well. So this created problem. Let us change this. Let us write here Simpson's rule, then maybe it will be solved. Okay, let us try it once again. Fortran Simpson's rule. Yes, now the problem is solved. So let us run the program. First clear it, dot slash a dot out, and yes, welcome to the Simpsons integration method using Fortran. Please insert the lower limit of integration. Okay, remember that our function is x square, and it should have x cube over 3 as integration. So if limit is 0 as lower limit and 4 as upper limit, and let us give number of subinterval as 10, then this should have, of course, this is 18. So in least number of least number of subinterval, the answer is 18. Okay, but the true answer is of course x cube divided by 3. 0 is of course 0, so 4 means 4 cube divided by 3 is 64 divided by 3. So answer is calculator 64 divided by 3 should be 21. Okay, the answer is far, is not very near. Okay, let us give some other value, okay, to have a correct answer. Lower limit is 0, upper limit is 4, and then sub interval, let me write 100. And yes, the answer is near to the answer. The true answer was this 21.33, and the answer is approximately near to 21. Okay, let us keep another example. Okay, lower limit 4, upper limit, lower limit 0, upper limit 4, and the integration is 1000. All right, so yes, answer is very near to the correct value. See, this is 21.33 is the right answer, and from the Simpsons rule we found value of 21.29, means near to the answer. Okay, let us further change the value of yan. Okay, so first lower limit 0, upper limit 4, and sub interval is previous time 1000, now it's 10,000. Okay, so answer is 21.32, so which is very near to the right answer, as right answer is 21.33. Okay, so this is how we can find the value of integration using Simpson's rule, but make sure that the answer is right in such a way that yan number of divisions should be very large. Okay, so let me write the limitation of this method. Alright, so to print over there, and then alright, so in here let me print okay, son of this method. Okay, sorry, yes, not sorry, cancelled. Okay, so number one is this method assumes the function to be linear. So print okay, next limitation is we can assume function to be linear to many functions only if we divide the interval in small amount, in small interval with small width. Okay, so we need to have value of yan as large as possible so that functions like this type of quadratic function will be linear. Okay, if the interval between a and b, sub interval between a and b are made so large. Okay, so this is the limitation, and we cannot use internally analytic functions by this method, because as we see, okay, let me save it and then again run that. Okay, let me compile it and then let us run the program. Lower limit is 0, upper limit is 4, and let us write okay 10,000 and lakh here. So yes, answer is very near to the target. Alright, so in 1 lakh sub intervals the answer is near to the true value. So I used, you can see here, I used a quadratic function. Even though this method assumes every function to be linear, then only it calculates the integrated value. Okay, so these are the limitations. Function to be linear even though the function is not linear. So to have a correct linear function from this type of function, this functional value should be divided into large number in such a way that the width is very small. Okay, so this is how we can do programming of Simpson's rule. The way is very easy, so please feel free to comment, and thank you so much for watching this tutorial. Thank you so much. It's me, Mohan.